My name is Zixiao Chen.
Hi everyone, my name is Xing.
We are junior students from Industrial and Operations Engineering Department, and this summer we're working with Professor Mark Daskin on a project called Room Assignment Problem.
Okay, so now let's take a close look at our project of this summer.
The room assignment problem is a special case of generalized assignment problem. The application of the generalized assignment problem includes the assignment of classrooms, time slot assignments, and other applications. In our project, a sorority in University of Michigan first raised a problem about how the members of this sorority should be assigned to different rooms. Things to take into consideration include members' preference on rooms, their preference on roommates, and the ranking of the members, which is represented by personal points. The ranking is a measure when considering the priority of assigning rooms to members. The goal of our project is to find an assignment that simultaneously minimizes the cost on both room preference and roommate preference. In other words, this optimization problem is multi-objective. Let's take an illustration here. The actual problem requires 50 persons to be assigned to 20 rooms. For simplicity purpose, let's assume that there are 10 persons to be assigned to 6 rooms, which is a much easier problem compared to the original one. The yellow dots represent members, and each row of blue squares represent one room. The number of squares is the capacity of that room. The white arrows indicate the rooms that are mostly preferred by the members. In this case, all the rooms are capable to accommodate members that love to live in that room. But in most cases, it is very common that a popular room could not meet people's demands. The yellow arrows indicate the rooms that are secondly preferred by the members. In the original problem, the members can select up to 20 rooms as their preferred rooms. Other than room preference, we also need to consider the 1-to-1 roommate preference. Here the green arrows indicate the members that other members prefer to live with, while the red arrows indicate the members that other people does not want to live with. When assigning two persons that do not wish to live together, the cost on room preference can be extremely high. Finally, when assigning the rooms to the members, we need to satisfy those with higher points first. That is to say, the preferred rooms and preferred roommates of those dots with larger radius should be satisfied first. This may look like unfair to other people, but this is how it works.
Okay, for the example problem, the scale is 10 persons and 6 rooms. So how do we solve the actual problem, which involves 50 persons and 20 rooms? First, we set up mathematical formulations, including the 4 inputs, the decision variables, the objective function, and the constraints. So basically, we are minimizing the cost composed by the room cost and roommate cost, subject to the room constraints, the roommate constraints, the room and roommate linkage constraints, and the binary property of room constraints. Also, we obtained parameters used in formulation from ranking of the students. Next, we programmed using Excel VBA and solved the previous formulation. Initially, we used linear programming solvers to solve the problem. This worked perfectly with smaller test cases, but turned out to be too time-consuming when dealing with the original sorority problem. Therefore, we had to establish heuristic methods. Let's go back to the example problem mentioned before, and here is the solution using What's Best linear program solver. The optimal cost is about 1 million, and the best assignment is that student 1 3 to room A, student 6 to room B, 7 to room C, and so on. As a comparison, here are the solutions obtained from our own heuristic solvers. The greedy method gives a cost about 10 times larger than the optimal, but the improved grasp and simulated annealing can give results that are very close to the optimal one. Finally, we explored the original problem with these solvers, and the results are displayed in this table. As a multi-objective problem, the cost is calculated by summing the room cost and roommate cost, so it is very important to see the trade-off frontier analysis. In the plotting, we are interested in the red dots, which represent best feasible solutions. For example, if a sorority emphasizes more on a better roommate arrangement rather than better room assignment, then the red points on the upper left corner of the plot are recommended. Okay, that's pretty much what we have done in the summer. From the sorority perspective, we have reduced a huge amount of cost in this assignment, and we will help the sorority implement the solutions, collect the feedback, and make improvements if possible. From our researching perspective, we have started from the optimization, explored several heuristic methods so far, and hopefully, we will come up with some new research papers, either in operations research field or in real implementation work with the sorority.
During my 11-week participation in Sure program, the first thing I realized is that I could actually apply what I have learned in classrooms into real-world application. As we had mentioned before, this room assignment problem was first raised by our sorority here in University of Michigan. And I think that what we have obtained now would actually help them a lot in utilizing their facility knowledge. Also, I learned a great deal of knowledge from this research experience. I got to know various ways in applying heuristic methods in solving optimization problems. Besides, the practice in using tools like Microsoft Excel VBA and its solvers greatly enhanced my ability in either researching or working in the future. Finally, I think my experience in Sure program this summer enhanced my teamwork skills. A lot of work was done in a way that cooperation and discussion played important roles. For example, in order to accomplish the implementation of a new heuristic method, Xing and I often had to work separately on different components and combine these components later in our work. This requires you to be very efficient in communicating with your teammate.
During this summer, I have learned a lot in formulating optimization problem from real-world scenario. I have enhanced my ability in operation research programming, and I have gained deeper understanding in this field from my professor Mark Daskin and great papers of previous work. But thinking back for these 10 weeks, what I realized the most and I want to share is my understanding of doing research. So at the start of a project, both Zixiao and I thought it would be a simple optimization problem and program solver in will be enough work. Things went perfectly until the second week. The original problem was turned out to be too big and it's like taking forever to solve. At the point we thought it would be the end of the project, Professor Daskin told us the way of doing research. So doing research is like hiking in a mountain. At some point we see the destination and all of a sudden it's blocked and we see nothing. It's like a walk with 3 steps forward and 2 steps back. Later we realized people are doing research because things are not clear in front of us and we need to discover it and find our own path to solve the problem. There's no deterministic way to success, so we have to equip ourselves with a prepared mind. Once blocked, we should have patience to read into papers and find roles over the previous people. And then use our creativity to find our own path and keep walking with faith. Finally, with the help from our professor, we found other heuristic methods to target the problem, and now we have found several ways to solve the problem.
Okay, so I think this was a great project. It's a real problem that the sorority would like to have solved. We were able to get real data that you were able to experiment with, and I think in the course of the summer you learned a lot about optimization, about how to formulate problems, about alternative formulations for this problem, about how to try to solve the problem optimally. I've been delighted with this project, and I hope you guys have had as much fun with it as I have. Good work.